Hi, everyone. So I'm Damien. I'm a network reliability engineer at Roblox. Today I'm going to explain how to manage your network device property differently. A little bit of background about myself. I joined Roblox a year ago, and before that I spent most of my career on working for different vendors. So I can say that it's been a very interesting experience for me to move from vendor to customers, and I'm hoping to share a bit of that knowledge with you today. In terms of the agenda, after the introductions, I'm going to spend some time, make sure we all have the same definition of what are the network device properties, talk a little bit about how, why they're important and the challenges. Then I'm going to try to explain how our industry and what is the state of how we are managing that today, and what are the challenges with those approaches. And then we'll look on how can we do that differently, and we'll finish with a question. So first, what is Roblox? Roblox is a social and gaming platform for kids. It's really the idea is that we don't build a game, we build the platforms, we build everything so that anybody can write their own games and play their own games. We today have over 2 million active developers and over 80 million active monthly users. For the network industry, for you, we are also the AS22697, and you can find us on many IXs. So 2018 for us has been very interesting years because our mission on the network side was pretty much to rebuild everything. We started the year with one legacy data center, layer 2, and the goal that was sold to the board was we will finish the year by replacing these data centers, building 2 new ones, building a global backbone, and 12 POPs with a very small team. And the state was that this time we had pretty much no automation. So that's kind of why I got hired. And the way we wanted it, the team was actually, we went way faster than expected. After only a few months, we had the switches and the router automated, then we went to the load balancer. But what I think is really interesting is that I think the real important decision that we made in the early day was that we invested on what you call the source of truth. And why it's important here is that the source of truth is what I call the property store. So all this presentation is about how we manage those properties, but at the end, we were able to centralize them in the source of truth. And really, I think our strategy was, we start with the source of truth, and then we integrate everything around it. We integrate our monitoring and alerting solutions, we integrate our system to generate the configuration, but at the end, your source of truth is really storage of data and information about your network. And it's only as good as the quality of the data you have in there. So to be able to achieve that at this scale, it was super important to start building tools that will help us populate this source of truth. And that's really what we're going to talk about today. I'm going to explain what we've been doing for 9 months and what has been really successful for us. Now, I've been surprised. A lot of people came to me and I talk about that. It's like, how come I never heard this story about the source of truth before? There's so many people talking about automation, they don't talk about that. And I have to say, I used to be this guy. I used to be this guy working for a vendor that will never mention the source of truth. Because the state of our industry is that there is no standard for a source of truth. There is no really product you can take. It's all built in-house. So it means that there's a lot of external solution that it's really hard for them to build a story around that to explain because they don't have something clear to explain or give to you. But from my point of view, it's still the most important part. Don't lose this part. Just a little bit of information about our domain stack. I found that people really ask questions about that. In terms of source of truth, we built something around an open source project called Netbox and Git. So whatever we couldn't put in Netbox, we actually are storing that in Git. For configuration, generation, deployment, we are using Ansible because it's really good at integrating with external source of information and managing all those data. And on the monitoring side, well, we started with Observium and SNMP because we want more integration with our source of truth. We are really moving toward more of a modern stack based on InfluxDB and Grafana, and we have some custom collector in the process. So let's look at what are those network device properties. What do I think when I talk about that? So for me, it's everything that really is unique to a device. And I will come from the name, all the IP addresses, but also the cabling, all the services, BGP session, anything that is really specific to a device. And if you think about it, I think our industry has done a lot of job and a lot of progress in terms of automating the configuration, templating. So we are able now, we have a few number of templates that we use in our networks, one per role. But we really just push the problem somewhere else because we still have to manage a set of unique device properties for each and individual device. We still have to manage all of that. And when you think about it, those network device property, they are direct reflections of your network design, of the cabling information, of the naming conventions. And one thing I didn't realize is how important the naming convention were and how much time we could spend talking about that. But what's really important is that you cannot mess with that. You have to respect that. And all of those will change all the time. So you have to manage the layout of the data center. It is really super important. What I realized when I joined is that we often oversimplify this complexity of that and how things are changing all the time. And honestly, if I take all the simplification I was doing when I was doing demos, I realized that it's just not applicable to production. And I've seen people just failing at automating their network because they just assume it's going to be homogeneous and simple. Let's take this example. Like if I have two IP fabric, a year ago, I probably have told you like exactly the same. You just put an ID. They're the same, 32 racks. But if you look at them, if I deploy them on two different sites, I will have to deal with the physical layout of my data center. And also what I learned is that for me today, it is as important to automate the management network than it is to make the production network and the console network, because I won't bring a device or rack to service until all of those aspects are done. And for example, the console servers that are very much based on copper are very dependent on how many the rows you have and where your console servers are. So if you're not set to manage those kind of differences, you'll really get in trouble. And what I found is every time we put something and you try to really like define and put a standards, somebody comes and bring you a new requirement, so you have to adapt. And then a vendor put your device in end of line thing. You have to create a new evolutions of that and manage a new evolution. And every time you think you're done, every time something happens, and every time you have to manage for that. So really my message here is you really need to prepare to have many versions of your device property. And what I found is that for every rule, there is an exception. So what you do is you follow the rule, except when you follow the exception, which what you just did is you just created a new rule that is based on this exception. And there's some business reasons you will never be able to push back on. So again, you should be prepared to have many versions of your properties. Just to give you some numbers, what we had to deal with this year at Roblox, we probably went a little faster than most because we really had very aggressive goals, but in 12 months, we had to manage 42 different revisions of our design and device properties. One of our device management switch, we had to manage 9 different versions because we wanted to reuse a lot of hardware. We had to manage 3 different sets of hardware, different architectures. So in just one role, we actually went up to 9 different versions. Just bring some numbers here also. People often ask about it, how many devices we deploy and all of that. But really, this talk is not about scale. I personally believe beyond like 10 devices, I will not want to manage anything manually. So some of you might find that big, some of you might find that small. It's really more FYI. So how are the industry, the organization managing the network device property today? And the first aspect is how do we generate them? Personally, I've seen 2 situations. People are doing that by hand, and I'm just going to assume that we all agree that we should never do that beyond 10 devices. And so the other school is people are using script and code. So let's focus on this one. Script and code, you can get a lot done very fast. You can have a very large number of device property. Technically, it is very flexible because you have all the flexibility of the code. But what I found is that it's really hard to maintain when you start having multiple variations. If you need to have nuances on how you manage things, that starts becoming really hard. Also, the issue with code is that you need to have software skill, and more complicated this piece of software is, the more complicated it is to interact. Meaning, every time a network engineers want to make changes, you will have to depend on somebody else, and then you just get into and slow down the innovation process to adapt your network infrastructure. And again, as you have more versions and more versions, it becomes really, really hard to maintain. How are we storing those properties? So I gave you a hint. One approach, our approach, is to use a central source of truth, either based on a database, on Git, all of the above. And the other approach is a lot of people, they don't have a source of truth. They consider the network to be the source of truth. I personally don't really think it is an approach that works very well with automation, but that's the states of our industry. So what can we do differently? And what do I mean by infrastructure as code and as code? I'm sure a lot of you are like, oh, still a guy that's going to tell us we need to write code and no. So it's not about that. For me, what infrastructure as code means is we have a system that is idempotent, that is version control friendly, and that is really self. So what I mean is like idempotent, I mean we'll have an input file and my system will be smart enough to understand all the steps that needs to happen to deploy those changes, and it will just not execute like action one by one without really thinking about it. So it has certain understanding of what you're trying to do. The system needs to be version control friendly, meaning it's going to have to work with some configuration files, put that in some Git repo, being able to make that as part of a review process, trustability, having multiple versions, configuration, just make it really index file easy. And safe and predictable, what I really appreciate with automation tools, then when I can see what is going to happen before it happens, when I can start running in check modes and have an idea of what the tool is going to do and not just be scared of what's going to happen when I press enter. So let me try to give you, and I'll start to go quickly on that, but a high-level overview of what I'm talking about here. To be able to achieve that, we need to have a source of truth, a user, and first we need to be able to have a configuration file, something that defines what we want to do. If I was a marketing guy, I would probably call that my intent. And we need a tool in the middle that we call here the network builder that will be able to understand and read this configuration file and interact with your source of truth. Then I'm reading and making the modification to be able to push all those information, very high level. So let's start to go down. If we want to have those safe modes, we want to be able to run in what I call plan, where the system is not making any changes. It just take my configuration files, render it, and show me exactly how it will look like if I were to actually execute that. And then, of course, the modes where I will actually make the changes. And if you do that, I believe you will be able to have really something that follows those infrastructure as code principle, independent, version control friendly, safe and predictable. So now the big question is, how do I actually define these configuration files? And the way I understood it when I joined is really people are thinking about it in terms of, when I build a rack switch, for example, I want to assign a /24 for the interfaces facing the server coming from this pool of addresses that has been reserved for this site. And I want a /32 for the loopback that has been reserved for another pool. Like, that's the kind of high level you want to think of. You don't really care which IP is assigned to which device, but you want to make sure that they are assigned from the right pool, the right type of resources that match all the requirements that you define. So how can we do that? So if you look back at the network builder, we have this module that is doing this idempotency, creating, talking with the source of truth. We won't really go into in details about this one today. But what I want to talk about is this, what I call the resource manager. And the idea is, what if you could manage all your resources as simply as you manage IP with DHCP? I found DHCP protocol very interesting because it's the pure definition of idempotent. A server doesn't have any state. Server is always asking the same question, give me an IP, give me an IP. And you never have to think where he is, where he's doing, like the infrastructure is providing that for it. And he doesn't have to think, do I already have an IP reserved? The query is always the same, can I have an IP? And all the complexities happening on the server side, the server will manage the pool of IPs that have been reserved, the system and how the query reaches the servers will define what type of IP we need to provide. And if the IP is already reserved, then we always give back the same IP. But if no IP are reserved on the table, then we allocate a new IP. What if you could do that for everything? The idea is that, what if we could create pools of resources, pools of ASN, pools of prefixes and loopback for a specific site, and build the systems where you will be able to say, hey, resource manager, give me an ISN from a device called device 1 in SFO. And the system, or give me a loopback. And the query, the resource manager will have this intelligence to be able to say, oh, no IP were assigned before, so here's one IP. And the next time you ask, it will know that an IP was already assigned, and it will always return the same one. So that really gives you this idempotent approach. And what we did is we created this kind of variable systems that let you define what you want, let you express this query. I want a loopback, and what you define is really what you want and from which pools you want it. And you say, I want a loopback, I want an IP, I want an interface, I want a VLAN ID, and I want it from a specific pool. And then the information of who is making the request, the identifier, is really passed at runtime. And the way it looks now, if we put that together, for example, is we're able to build those configurations files where we're able to, using those variables, to express in a very generic way, but really very close to the way we think on what we need to allocate for a specific device. I want an ASN from a specific pool, I want a /31, I want multiple of them, I want a loopback. And the idea is that as you pass that through the resource manager, you will get all your information resolved. And then you can pass that to the next block. You will make sure that all the changes are properly propagated. So now when you're here, we're doing one device. But we're very close to actually turn that into a template. Like, I really have to pass a specific ID or some more information, and I can start seeing that as a template. And this exact template, I will be able to reuse that across multiple racks. So now I have one template, the same definition, the same architectures, and those racks, I can propagate that everywhere. And if one of my racks or multiple of my racks have a different template, it's super easy to create multiple of them with different variations and keep track of that and understand which design go on which rack. And if things change, I can create new revision of that and so on. Now, often the design is really based on the location of the device. You need to understand which console servers you need to connect to, which cluster, which pods you're part of, what out-of-band network you're part of. So really, we needed to provide more information on the way we were defining that. So what we did is we try to build what we call the context resolutions. Now I actually try to think of it as the facts of the rack. I don't know if you're doing automation usually that speaks, but the idea is that we have a system where at the beginning, we actually collect a lot of information about the specific location of the device we're trying to generate resources from. Where is it, which parts, and we provide all those information as variable, and we are leveraging, like, on top of whatever I showed you, we are injecting those variables using Jinja, and it let us really make all of those templates now really location independent. And so this template that previously was good for one site or one pod, now I can reuse that on any of my sites as long as they are using exactly the same design. So if we summarize, for us, the network builders, there's really 3 components. We need to resolve the context, then there's the resource manager, and then there's component that is really managing the modification of and the interaction with the source of truth. So what's next step for us? The first is we love to get feedback. We haven't seen many people taking this approach. It's been very successful for us, but I'm sure we can do better. So whatever you like it or don't like it, I'd love to hear your feedback. And would love to bring some of those components piece by piece into more open source and share that and collaborate. We started that, but again, if you're interested to take a look, participate, collaborate, reach out to me. Thanks a lot for your time, and if you have questions, happy to answer.
Andrew Danforth with Linode. Great presentation. Can you talk a little bit more about that resource manager? Is it something of an abstraction? Is it, excuse me, is it a server? And then also queries to that resource manager. You kind of compared it to DHCP. Is it a custom protocol? Is it just an API call?
So for us today, we manage that as a Python library. We purposefully run it outside of the source of truth because the idea is that when you're in plan mode or when you do something, you actually don't want to propagate your changes. So there's this part where everything runs in memory. So it's a Python script that will interact on one way with the source of truth and the other one with the, if you're familiar with automation, it's very much inspired from something like Terraform, where you have a tool that will, give you some idea of what's going to happen before it happens.
Thank you.
Hi, Louis Bolanos with Box. I have 2 questions. So can you talk about a little bit on your approach for defining inventory for the initial data seeding for SOT? And then how do you keep that data valid?
So we use the builder to input our devices. So the workflow we agreed is that even before the device gets racked, we actually populate everything using the network builder. So that's how we do that. Now, we haven't really went that far, but the idea is that we would like to start using the builder in plan mode on a daily basis. And since in plan mode it will tell us what's changed, the expectation is whatever part of the network we already provision or define in the source of truth, it should tell us nothing will change because it's all final state based, like we define what we want. So, and our plan is that as we do that, the system will be able to identify drift into what we define and keep track in the source control and what is actually deployed. We haven't gone that far.
Okay, thank you.
Yeah, Matt Peterson, OpenFiber in this context. Did you guys look at using the netbox configuration context capabilities? It sounds very similar.
So we haven't looked at, we're a couple of versions behind. My understanding is the configuration context, as far as I know, and maybe I don't have the whole information, will save those context information. They will not generate them for them. And even that will not generate the cabling, that will not generate the IP addresses. So I don't think it's probably something complementary. Yeah. But I think it's more, we could put something in there that today we're putting in Git. But even that, we have done some analysis and we know that there's still a lot of things we cannot put. So having this mixed approach has been working so far.
And then a follow-up question, you mentioned that you're pulling data from Netbox and then Git, and are you merging that as part of your Jinja 2 template of things that Netbox didn't have proper objects for? Is that kind of the use case there, or is it something else?
So Netbox is the source of truth for cabling, IP, devices, and a lot of things. So we had actually to extend Netbox to create our own set of APIs to really have be able to get a consistent type of data that will define one device, and then yes, we ingest that and feed that into the Jinja template.
Great, thank you.
Hey, Damon, how are you? Seth Lane, Major League Baseball. So this is all about build and deploy. Have you tried to marry it to state yet? Is that like a future thing? So as far as operate goes, and to compare it back to the original config?
So what we're doing is, for us, monitoring and actual state and all of that is another component. And everything, since that's why we want to have everything in the source of truth in a central place where everybody can look like, with this tool, we populate the source of truth. We have other tools that extract things and deploy in configuration. And every single operational monitoring and alerting actually refer to that to understand how is the network supposed to run at this time. And it will automatically understand the devices that are in maintenance mode, the ones that are not active, how things are connected, and all of that. So it's that's why it's in the middle.
Okay, thanks.
Hi, Victor from Workday. Do you guys do any validation in emulated environment in your CI/CD pipeline to production?
We're actually working closely with the team at Badfish on trying to leverage Badfish to do that. So we're not fully there yet, but work in progress.
Thank you.
Cool, thanks a lot. Thanks for staying all the way.